Why Your Stardust, a calm night story of cosmic origins. In this story we discuss the 3 sections after introduction, so let's start. Introduction, the universe before light. Close your eyes and imagine a time before time. Not just an empty night sky, but a universe so young that no stars existed at all. This was the cosmic dark age, a period lasting nearly 100 million years after the Big Bang, when the entire universe was nothing but a vast, formless sea of hydrogen and helium gas, slowly cooling as space itself expanded. There were no planets, no galaxies, not even the faintest glow of starlight. Just an endless, perfect darkness stretching across the infant cosmos. In this primordial darkness, something remarkable was happening. Tiny quantum fluctuations from the Big Bang, small variations in density, meant some regions of this gaseous soup were ever so slightly denser than others. These minute differences would change everything. Gravity, the universe's great sculptor, began its patient work, pulling atoms together in these denser regions. What started as microscopic clumps grew over millions of years into massive clouds of gas, each containing enough material to form millions of stars like our Sun. As these gas clouds grew denser, they grew hotter. From just a few degrees above absolute zero, temperatures in their cores rose to thousands, then millions of degrees. The hydrogen atoms within, normally repelled by their positive charges, were now moving so fast that when they collided, they overcame this repulsion and fused together in a process called nuclear fusion. This was the moment of creation, the birth of the first stars in the universe. These first stars were unlike anything we see today. They were behemoths, hundreds of times more massive than our Sun, and burning at temperatures exceeding 100 million degrees at their cores. Their intense ultraviolet radiation fundamentally changed the universe around them, stripping electrons from atoms in a process called reionization that transformed the cosmos from opaque to transparent. These stellar giants lived fast and died young, their lifetimes measured in mere millions of years rather than billions. Most astonishing of all, these first stars contained only the simplest elements, hydrogen and helium, for they were born before any heavier elements existed. When they died in spectacular supernova explosions, they became the universe's first alchemists, forging heavier elements like carbon, oxygen, and nitrogen in their final moments. These elements, created in stellar furnaces and scattered across space by supernovae, would become the building blocks of everything to come: planets, oceans, and eventually, life itself. This is where your story truly begins. Every atom in your body that isn't hydrogen, the carbon in your cells, the oxygen in your lungs, the calcium in your bones, was created inside stars that lived and died before our solar system even existed. You are literally made of stardust, the ashes of long-dead stars that exploded billions of years ago. The iron in your blood was forged in the heart of a massive star during its final moments before going supernova. The gold and jewelry you might wear was created when 2 neutron stars collided in a cataclysmic event that sent precious metals streaming across the galaxy. As we explore this incredible story, we'll follow these atoms on their extraordinary journey, from their creation in stellar furnaces, through the vast emptiness of interstellar space, to their eventual incorporation into our planet and all life upon it. This isn't just astronomy or chemistry, it's the story of how the universe organized itself over billions of years to become aware of its own existence through you. The atoms that make up your body have traveled across galaxies, survived supernova explosions, witnessed the birth and death of countless stars, and now, for this brief moment in cosmic time, have come together to form you, a living, thinking being capable of looking up at the night sky and wondering about your own origins. This is perhaps the most profound realization science has given us, that we are not just in the universe, but that the universe is in us. Now start the section 1, the celestial forge, where your atoms were born. In the unimaginable heat and pressure of stars, the very elements that compose your body were first created. This isn't poetic exaggeration but scientific fact. Every atom in your being that's heavier than hydrogen was forged in the nuclear furnaces of stars that lived and died before our solar system existed. Let us journey back to these primordial stellar factories where the ingredients of life itself were first created. The first generation of stars, known as population 3 stars, were unlike anything in our current night sky. These cosmic behemoths formed from pure hydrogen and helium, uncontaminated by heavier elements, allowing them to grow to staggering sizes, some reaching 300 times the mass of our Sun. Their cores burned at temperatures exceeding 100 million degrees Celsius, creating conditions so extreme that they could fuse atoms together in ways modern stars cannot replicate. These stellar giants lived violently and died young, their lifetimes measured in mere millions of years rather than billions. But in their brief, brilliant lives, they accomplished something extraordinary. They transformed the simple elements of the Big Bang into more complex ones, seeding the universe with the raw materials for planets and life. Within these stellar furnaces, a remarkable alchemy took place. Deep in their cores, where temperatures and pressures reached unimaginable extremes, hydrogen atoms were forced together to form helium. As the star aged and its hydrogen fuel dwindled, it began fusing helium into carbon and oxygen. In the most massive stars, this process continued in concentric shells like the layers of an onion. Carbon fused into neon, neon into oxygen, oxygen into silicon, and finally silicon into iron. Each stage occurred faster than the last, with the final silicon to iron transition taking just days before the star met its catastrophic end. This relentless nuclear cooking created nearly all the elements essential for life as we know it. Iron marked the end of the line for stellar fusion. Unlike lighter elements, fusing iron atoms doesn't release energy, it consumes it. When a star's core becomes primarily iron, the delicate balance between outward pressure from fusion and inward pull of gravity is broken. In less than a second, the core collapses from about the size of Earth to a sphere just 20 kilometers across, a neutron star. The outer layers of the star, suddenly without support, come crashing down at nearly a quarter the speed of light before rebounding in the most violent explosion known in nature, a supernova. The death throes of these massive stars created even heavier elements. The incredible energy of a supernova, briefly outshining its entire galaxy, provides the necessary conditions to form elements beyond iron in the periodic table. Gold, silver, iodine, uranium, all the heavy elements in your body were created either in the final moments of a star's life or in the even more violent collisions of neutron stars. These cataclysmic events scattered these newly forged elements across interstellar space, where they mixed with vast clouds of gas and dust. This stellar material didn't remain scattered forever. Gravity, the great architect of the cosmos, began pulling these enriched clouds together over millions of years. Some atoms found themselves in dense regions that would eventually form new stars and planets. Others became part of vast molecular clouds light years across, cosmic nurseries where future solar systems took shape. A select few of these atoms, through a series of extraordinary cosmic coincidences, would eventually become part of a particular. The story of how these wandering stardust particles came together to form our solar system is no less remarkable than their creation in dying stars. But that is a tale for our next section, where we'll follow these atoms as they become part of the Earth and, eventually, part of you. For now, as you gaze at the night sky, remember this: the same forces that lit the first stars and scattered their ashes across the cosmos are the very reasons you exist today. Every element in your body, from the oxygen you breathe to the calcium in your bones, carries within it the echo of these ancient stellar explosions, a heritage written in atomic code that connects you directly to the dawn of time itself. And now the section 2, the Odyssey of Stardust, from cosmic clouds to living cells. The atoms forged in stellar furnaces now began an even more improbable journey, one that would ultimately lead to the miracle of life. After being scattered across light years of space by supernova explosions, these elemental travelers found themselves drifting through vast molecular clouds, swirling in cosmic eddies where new stars were being born. These stellar nurseries, cold and dark by human standards but teeming with potential, became the next chapter in our elemental saga. Here, in the freezing vacuum of space where temperatures hovered just a few degrees above absolute zero, the stage was being set for the formation of our solar system and, ultimately, life on Earth. About 4.6 billion years ago, a particular cloud of gas and dust, enriched with elements from countless generations of stars, began to collapse under its own gravity. Perhaps triggered by the shockwave from a nearby supernova, this cloud started spinning faster as it contracted, flattening into a disk with a growing protostar at its center. The heavier elements, including those that would one day course through your veins, tended to stay closer to the center, while lighter gases like hydrogen, helium dominated the outer region. Over time, these materials began clumping together, forming ever larger bodies through a process called accretion. Dust grains became pebbles, pebbles became boulders, and boulders became planetesimals, the building blocks of planets. The young Earth that formed from this cosmic construction project was a vastly different world from the one we know today. In its infancy, our planet was a molten sphere, constantly bombarded by leftover planetesimals and comets. These violent collisions delivered not only the heavy elements created in stars but also something even more precious, water and organic molecules. The iron that now carries oxygen in your blood once rained down onto Earth's surface in a period called the Late Heavy Bombardment, when millions of asteroids pummeled the inner solar system. The gold in your jewelry might have arrived in a similar fashion, deposited during Earth's formative years when the planet was still cooling from its fiery birth. As Earth began to cool, these starborn elements started forming the first stable minerals and compounds. Iron sank to form the core, while lighter elements like silicon and oxygen formed the mantle and crust. Water vapor in the atmosphere condensed to form the first oceans, creating vast chemical laboratories where simple molecules could interact. Near hydrothermal vents on the ocean floor, where mineral-rich hot water met the cold deep sea, conditions were perfect for more complex chemistry to occur. Here, the carbon from ancient stars began forming chains, the nitrogen started building amino acids, and phosphorus became incorporated into molecules that could store information, the precursors to DNA. The transition from non-living chemistry to biology remains one of science's greatest mysteries, but we know it happened because you're here to ponder it. Those stellar elements, after billions of years of cosmic travel, became part of self-replicating molecules that grew increasingly complex. The iron that once fueled a star's fusion reactions now helped catalyze biochemical processes in primitive cells. The oxygen that was once a byproduct of stellar nucleosynthesis became essential for respiration. The calcium that formed in supernovae now provided structural support in cellular organisms. Over eons, these elements cycled through countless life forms. The carbon in your cells might have once been part of a dinosaur's breath, a prehistoric fern, or a microscopic organism in an ancient sea. The nitrogen in your DNA could have passed through the roots of the first flowering plants. The oxygen you're breathing now has been recycled through Earth's atmosphere countless times, having been inhaled by creatures from every era of our planet's history. This continuous recycling of stellar material means you quite literally contain atoms that were once part of every living thing that came before you, from the mightiest dinosaurs to the simplest single-celled organisms. As life became more complex, so too did the ways these elements were used. The calcium that once simply helped maintain ocean chemistry became the framework for skeletons. The potassium and sodium that drifted through interstellar space became essential for nerve impulses. The copper in your enzymes might have spent billions of years in space before helping your cells produce energy. Every biological process in your body, from the firing of neurons in your brain to the contraction of muscles in your heart, relies on these starborn elements performing their ancient dances in new, life-sustaining ways. But how did these biological processes lead to consciousness? How did Stardust become not just life, but a mind capable of understanding its own origins? That remarkable transformation, from thinking atoms to atoms that think, is the next chapter in our cosmic story, one that begins in the primordial seas but culminates in the extraordinary complexity of the human brain. It has become aware of its. Now the last section 3, the universe awakens, when Stardust learned to think. The most extraordinary transformation in cosmic history occurred not in the hearts of stars or the vastness of space, but within the intricate folds of the human brain. Here, Stardust achieved its most remarkable feat, it became conscious. After 13.8 billion years of cosmic evolution, hydrogen atoms forged in the Big Bang, oxygen created in dying stars, and carbon scattered across the galaxy by supernovae finally organized themselves into something that could contemplate its own existence. This is the story of how the universe, through you, became aware of itself. The journey from simple cells to conscious mind spans nearly 4 billion years of Earth's history. Your atoms took part in every step of this incredible evolution. The iron that once helped ancient bacteria metabolize now carries oxygen in your bloodstream to fuel your thoughts. The calcium that strengthened the skeletons of early fish now enables your neurons to fire. The phosphorus that was once dissolved in primordial oceans now forms the backbone of your DNA, preserving genetic memories older than humanity itself. Each element in your body carries with it both its stellar ancestry and its biological history, a dual inheritance written in atomic structure and evolutionary function. The human brain represents the most complex arrangement of matter we know of in the universe. Within its 3 pounds of tissue, approximately 86 billion neurons form connections numbering in the hundreds of trillions. The electrical impulses racing through this network right now, allowing you to comprehend these words, are made possible by sodium, potassium and calcium ions moving across cell membranes. These same ions once drifted through interstellar space, utterly unaware that they would one day become thoughts, memories and dreams. The carbon atoms forming your brain's organic molecules were created in red giant stars. The oxygen keeping those neurons alive was forged in supernovae. Even the zinc that helps regulate your brain's chemistry was likely created when 2 neutron stars collided in a spectacular cosmic event. Consciousness emerges from this symphony of stellar elements working in concert. When you remember your first kiss, solve a difficult problem, or feel wonder at the night sky, you're using atoms that have existed since before our solar system formed. The iron in your blood that now helps transport oxygen to your brain may have once been part of a dinosaur's circulatory system. The water molecules hydrating your cells have cycled through Earth's atmosphere for billions of years. Your very ability to question your origins comes from elements that themselves have no memory of their incredible journey, yet have somehow combined to create memory itself. This self-awareness represents a profound cosmic irony. The universe, through billions of years of trial and error, has created something that can understand its own workings. The carbon in your brain studies the carbon in distant galaxies. The oxygen in your thoughts measures the oxygen in interstellar clouds. The calcium that helps form your memories was created in the same stellar explosions that shaped the cosmos. In you, the universe has developed not just eyes to see itself, but a mind to contemplate itself. Your curiosity about the stars is, in a very real sense, the universe becoming curious about itself. As you lie beneath the night sky, consider this: the atoms composing your body are temporary travelers. They have been part of stars, planets, and countless life forms before you, and will continue their journey long after you're gone. But during their brief time as part of you, they have achieved something extraordinary: they have given the universe meaning. Through your capacity for love, art, science and wonder, Stardust has transcended its material nature to create beauty, truth and understanding. The same forces that shaped galaxies have shaped your ability to appreciate them. The circle is now complete. Stars died so that you could live. Their ashes became your body, their energy fuels your thoughts, and their legacy lives on in your curiosity about them. When you look up at the night sky, you are the universe looking back at itself across billions of years, Stardust contemplating Stardust, the cosmos made conscious. This profound connection between the microscopic and the cosmic, between the fleeting and the eternal, is perhaps the greatest gift science has given us, the knowledge that we are not merely in the universe, but that the universe is in us. As you drift to sleep tonight, remember that the atoms in your dreams have traveled farther than any human spacecraft, survived more violent explosions than any earthly catastrophe, and participated in the grand cosmic story that led from the Big Bang to tonight. The universe will continue its evolution long after we're gone, but right now, in this precious moment of cosmic time, it has become aware, reflective, and filled with wonder, through you. Rest well, little universe. The stars that gave you life will keep watch until morning. Good night.